Culmann's method. It is a very simple method. So you take one slope, okay, draw the slope to the required scale because you cannot draw entire height of the slope. So now you select one failure surface. Let me select one failure surface. But my interest is to tell you that don't draw here. You see, uh, circular failure surface because you know in Culmann method assumes a failure surface is planar. You can ask me, sir, why you are telling like this? Because you know Culmann method is basically having background in earth pressure. Culmann's method, why the Culmann's method is not popular as method of slices? Because you see, the Culmann method assumes failure surface is planar. So we are not ready to accept this because we ready to accept failure surface is circular in case of slope stability analysis. That's why Culmann's method is not as much as popular as method of slices. And but I can tell you, I just mentioned the limitation of Culmann's method, but Culmann's method is pretty good in case in plane wedge failure. In case if you think if two sliding blocks are there, where you can use Culmann's method, it's pretty good. Maybe in rock mechanics, people can adopt this whenever two jointed rocks are there, where you can do this analysis. But in case of if two, in case of non-homogeneous soil deposits, we can go for Culmann's method. But many times we are happy with method of slices. So anyhow, I will tell you. So the way we are calculating factor of safety, can anyone tell me now? C, length of arc. Now you know n into tan phi by sigma t, sigma n. So here you see, let me tell you, this is our conventional method of slices, normal force, tangential. But here what we are discussing is Culmann's method. Here you see, I am considering only one failure surface. Only one failure surface. So angle is theta f. Angle is theta f. Let me tell you once again. Here the failure surface is planar. Failure surface is planar. The angle of failure surface is theta f. Now I can divide this W into two components. Can anyone help me now? How to resolve weight into two components now? I have W. What is this force now? This is tangential force and this is normal force. N is W. Anyone tell me now? This is N now. W cos theta F. W cos theta F. What about T now? What about T now? Can anyone help me now? How to calculate? So how to calculate? See here you see this is I actually here you see once again I will explain you. So this is the failure plane, whatever I consider. It is a planar now. So what I am trying to tell you. So W is the weight of the sliding wedge. W is the weight of the sliding wedge. But it is triangular now. The shape of the triangular. Now my question is how to calculate N, how to calculate T. Can anyone tell me? Please help me now. What is N? What is T? Or an help chestara naku. So this is theta F. Theta F. So can anyone tell me how to calculate N in case of Culmann's method? So and how to calculate T? N T. Because I'm not doing any method of slices. That's why I'm not adding any sigma in front of N. I'm not adding any sigma in front of T. Only one N, only one T. Can anyone help me now how to calculate N now? ఎవరైనా హెల్ప్ చేస్తారా నాకు? మిమ్మల్ని అడగడం వల్ల నాకేమవుతుందంటే మీరు ఆన్సర్ చెప్తే వెల్ అండ్ గుడ్, ఇట్ విల్ సేవ్ టైం. ఓకే, దట్స్ వై ఐఎమ్ టేకింగ్ యువర్ హెల్ప్. సో నౌ దిస్ ఇస్ theta f. Here you see the angle made by the failure plane with horizontal theta f. So what is N now? This angle is theta f, obviously. Now what I am expecting N is N is, can anyone tell me what is N? Is it side W? W? Now resolve weight into, because weight is vertical, many times I'm telling you, weight is vertical, it is vertical, and it has its own center of gravity. Now what I'm asking you, tell me these two values. Resolve the weight into two components. This is tangential component, which is acting in the downward direction. That means it is a devastating force. And we have normal force. So can anyone tell me how to calculate normal force now? It is theta F. N is, N is W cos theta F. What about tangential force? W sin theta F. So now you see, don't worry, I will explain you cos theta F, sin theta F. Factor safety is equal to, factor safety is equal to C into length of the arc, W, W cos theta F tan phi by W sin theta. Sin theta. This is the answer. How to calculate factor safety? How to calculate factor safety using Culmann's method. See here, entire method is explained. Here you see Culmann's method. Now, anyone can tell me what is the difference between method of slices and Culmann's method? Both are analytical methods. Both are analytical methods. That means by using an equation, we can able to calculate factor safety. They are mathematical, analytical. They are not graphical, to be frank. So now my question to you is, so how to calculate factor safety? So as you know, what is the fundamental difference between Culmann's method and method of slices? So can anyone tell me? So the fundamental difference is the way we are treating the failure surface. So can anyone tell me? So in Culmann's method, the failure surface is assumed as planar. It is not circular. It is not an arc. So that's why now the problem is simplified. Actually, the problem is simplified because if you consider a circular surface, there are some problems. Length of the arc is difficult to calculate. Here you see now length of the arc is became length of the chord. You see in the last class, in the last discussion, here what is this? This is length of long chord. So your length of the long chord is now length of the failure surface. So that's why the problem is simplified by Culmann. The problem is simplified by Culmann. So in previous problem, when we are discussing method of slices, dividing the entire sliding wedge into number of slices. So this is sliding wedge, no doubt. The wedge. This is the weight of this. This is a wedge involved in sliding. This is the wedge involved. That's why you see when you are reading the in book, you may feel difficulty. Sir, what is sliding wedge? This the portion within this failure surface is sliding wedge. So here I am seeing triangular wedge. I'm not going to show any circular wedge. So because Culmann's method believes that failure surface is planar. So then entire problem becomes simple now. The entire problem became simple. So I can get factor safety. Now you have W cos theta F, W sin theta F. What is W? Don't hesitate to ask me. W means gamma into area into 1. Now you can ask me how to calculate area. How to calculate area of the triangle. Can anyone tell me how to calculate area of the triangle? What I have to do now? Take one vertical distance. Okay, now what is how to calculate W? Gamma into area of base into height. This perpendicular distance is height of base into base is known. Base is nothing but length of the failure surface. Now you